Hello there and welcome to a brand new lesson. This is Hab Beyond Numbers where we learn maths the easy way. In this lesson, we are looking at question number 4 of WASSCE 2026 core maths paper. On the left-hand side are answers to trial exercises I gave on question number 3. If you've not done that, you can check on the playlist and then quickly do that. By the end of this lesson, you should be able to understand how to simplify expressions with common bases. Be able to factorize expressions by taking out common factors. To be able to solve exponential equations by equating powers when the bases are the same. And finally, be able to work with fractional indices and powers. Without much I say, let's quickly look into it. So question number 4 is as we have on the screen, and it says, given that 10 to the power x plus 14 to the power x all over 15 to the power x plus 21 to the power x is equal to 2 whole number 1 over 4, find the value of x. Before we look at this question, when it comes to indices, there are some basic laws we need to know. And knowing these laws would help you solve more complex problems as what we have over here. The first law of indices is what we call the product law, which says if you have a to the power m, that is multiplying a to the power n, it says so far as the bases are the same, we only write the base and then we add the exponent. The second law is called the quotient rule. The quotient rule is also saying if you have a to the power m and you are dividing it by a to the power n, since the bases are the same, you see, this is what we call the base. So since the bases are the same, we just subtract or find the difference between the exponent. The third one, there are more, but then we are just looking at those that will be necessary for this question. It says if you have a, b, and it's to the power n, we can always, whether m or n, we can always distribute m to both factors. That is to say, we have a to the power m times b to the power m. These are the three rules we will need here. And always take note, we can only equate two index notations if the bases are the same. So if the bases are not the same, do not ever think of equating them. Hence, since this involves an equation, we will have to look for a way to make sure we get the same base. First of all, we have 10 to the power x plus 14 to the power x, and it's all over 15 to the power x plus 21 to the power x, and it's equal to 2 whole number 1 over 4. Now, for 2 whole number 1 over 4, we can rewrite it as an improper fraction. So that becomes 2 times 4, which is 8 plus 1. We have our 9 over 4. Then we focus on 10 raised to the power x plus 14 raised to the power x. Now, let's focus first of all on the numerator. And then if you get the idea as to how to evaluate it, you would also try that of the denominator. So we have 10 to the power x plus 14 to the power x. The bases are not the same, you see. So we would want to apply the third rule we just discussed. We have what we call product of prime factorization. Let's rewrite 10 as a product of prime factors. In writing 10 as a product of prime factors, we know it is simply a 2 times 5. You see, and for 14 as product of prime factors, it is 2 times a 7. Now, this 10 here, we are going to substitute it for 2 times 5. So instead of 10 to the power x, which is 2 times 5, we are going to rewrite it as 2 times 5 raised to the power x. And the same applies to 14. So for 14 to the power x as well, we are going to write it as 2 times 7 all to the power x. Having done this, we will now substitute this numerator we have here for these we have come up with. So that instead of the 10, we are going to rewrite it as what? 2 times 5 all to the power x. And then instead of the 14, we have 2 times 7 all to the power x. I hope you get the whole concept now. So we do the same also for the 15. So for the 15, which is 15 to the power x and then plus 21 to the power x. 15 can be written as 3 times 5. Instead of 15, we are going to stick to 3 times 5. And then instead of the 21, 21 is also going to be written as what? The 3 times 7. So 15 to the power x now becomes 2, 3 times 5 all to the power x. And then 21 to the power x also becomes 3 times 7 all to the power x. So we do that necessary substitution right here. So that instead of 15 to the power x, we are going to write 3 times 5 to the power x. And then plus, instead of 21, we write 3 times 7 all to the power x. Now we apply the third rule we discussed. It says if you have two terms in a bracket and it's to the power m, just distribute the m to both. So that in this case, this x affects the 2 and affects the 5. Affects the 2, affects the 7, affects 3 and then 5, and then also that same over here. Hence, let's rewrite it. So what do we have here? We have a 2 to the power x, then times 5 to the power x, you see. And then plus a 2 to the power x. Then the next one gives us a 2 to the power x times 7 to the power x. All over. We go to the denominator. 3 to the power x times 5 to the power x. And then our plus. So plus 3 to the power x plus 7 to the power x is equal to our 9 over 4. Now that we have it this way, we now check and see if there is a way we can factorize. Talking of factorization, we have 2 to the power x here and we have 2 to the power x over here. So for the numerator, both terms have something in common. For the denominator as well, we have 3 to the power x and then 3 to the power x. So what we are going to do is to factorize them. So in factorizing them, for the numerator, we are going to bring our 2 to the power x out. Then into bracket, we just have the 5 to the power x. And then plus, there is 2 to the power x over here, which has been factorized out. So we are left with 7 to the power x all over. The denominator also does same. So we have our 3 to the power x being factorized outside. Then our 5 to the power x plus the 7 to the power x. We are saying that is equal to 9 over 4. At this point, can you guess what we are going to do next? When it comes to simplifying fractions, we can only cancel out when there is a product. Talking of product, this term here is multiplying this other terms because you see it is in front of the bracket, and the same applies to this term. It is also multiplying this other term. You see, so since they are multiplying, and you realize that this term is the same as this term, then we can easily cancel out. You see, so at this stage, we can cancel out this term and this term because they are the same. And with that, we'll be left with a 2 to the power x over 3 to the power x, which is equal to 9 over 4. And if you look at it carefully, we can even change this 9 and then the 4 as well to powers or bases of 2 and 3. So that becomes 2 to the power x over 3 to the power x equals, the 9 becomes a 3 squared, and then 4 also becomes a 2 squared. Now, after writing it like this, we can then factorize the x out and factorize the squared out as well from both. So that we have 2 over 3 all to the power x is equal to 3 over 2 all to the power 2. Now, this then brings us to another law of indices that we didn't consider. There's a law of indices that says that if you have a over b all to the power n, it is simply equal to a to the power n all over b to the power n. And that is what we have considered here. There is also another law of indices that says if you have a to the power a negative n, you can rewrite it as 1 over a to the power n. That is the negative index, the law that applies to negative index. When this law is applied to quotients, we are going to say if you have a over b all to the power negative n, all we do is we reciprocate the fraction. So that becomes b over a all to the power positive n. If you take note, this is what has happened over here. You see, so all of a sudden, our 2 over 3 reciprocated and became 3 over 2. You see, so if we want that to be applied in this case, then we are going to rewrite what we have here, which is 2 over 3 all to the power x. Then we reciprocate this particular fraction so that it also becomes 2 over 3. But since we have reciprocated it, then it simply means this power should be negated. That becomes negative 2. That is applying the rule we just wrote here. You see over here it is a over b and then negated. But if we reciprocate the fraction, then the exponent should become a positive. So we have reciprocated the fraction so that it just looks like what we have here. And then we negate the power. When we started, I said we can only equate index notation if the bases are the same. We can now see that the bases are the same. This is 2 over 3 and this is also 2 over 3. Hence, equating the exponent, we can then conclude that what x is equal to negative 2. Very, very simple. I hope it is clear. So we'll end this question here, but as usual, I'll leave you with some exercises so you try on your own just to test your understanding. So here are 5 questions just based on what we just did. And our advice, you pause and then attempt them to test your understanding. After which you can check on the next lesson to review your answers. This is How Beyond Numbers, where we learn maths the easy way. If this is your first time on this channel and think it will be of help to you, you can choose to subscribe. See you in our next lesson. Bye for now and do stay safe.